In this lesson, we will talk about writing terms of a sequence from the nth term. So in mathematics, a sequence is basically just an ordered collection of objects called elements. And there are two types. There's a finite sequence, which essentially ends at some point, and an infinite sequence, which does not. The way that we describe the terms or elements of a sequence, notice we've got the subscripts, so a sub 1, a sub 2, that just means the first term, second term, nth term, etc. So for these first questions, we're just going to write the first four terms of the sequence defined by the nth term. So that means this is telling us to find the nth term, take n squared minus 4. So to find the first term, we're plugging in 1, we're squaring it, and we're subtracting 4. And 1 minus 4 is negative 3. A sub 2 means we're taking 2 squared minus 4, which is 4 minus 4, or 0. A sub 3 would be 3 squared minus 4, which is 9 minus 4, which is 5. And then a sub 4 is 4 squared minus 4, or 16 minus 4, which of course is equal to 12. So the first 14 terms of the sequence would be negative 3, 0, 5, and 12. The second sequence, again defined by n, is just n plus 3. So a sub 1 would be 1 plus 3, which is 4. A sub 2 would be 2 plus 3, which is 5. A sub 3 is 3 plus 3, which is 6. And a sub 4 is 4 plus 3, which is 7. So 4, 5, 6, 7. Typically in sequences, then we would just write the ellipse at the end, the dot, dot, dot that says, yes, this pattern is going to continue. Here are a couple more for us to try. These are a little bit different because, as you can see, the n is now an exponent as opposed to being multiplied or added. So a sub 1 would be negative 2/3 to the first, which would be negative 2/3. A sub 2 would be negative 2/3 squared. And remember, when you square a quotient, you're squaring the numerator and the denominator, so that's 4/9. A sub 3, or the third term of the sequence, would be cubing everything. So negative 2 cubed is negative 8, and 3 cubed is 27. And then a sub 4 would be taking everything to the fourth power. So that would be positive 16 and 81. So those are my first four terms, and again, that pattern would continue. For the second, notice I've got the negative n. So a sub 1 would be 2 times 4 to the negative first. And remember, the negative exponent tells us to essentially make it a denominator, or do the reciprocal. So this is 2 times the fourth, which is 2/4, which is 1/2. A sub 2 would be 2 times 4 to the negative 2. 4 to the negative 2 would be 1 over 4 squared, so that's 1 over 16, which gives me 1/8, so 2 and 16 reduce. A sub 3 gives me 2 times 4 to the negative third, which gives me 2 times 1 over 64, which is 1/32. And the last one, 2 times 4 to the negative 4, which is 2 times 1 over 256, which is 1 over 128. So again, that pattern would continue. I do want you to notice that this negative exponent did not change the sign of any of these. So we didn't turn any of these into negative values. The negative exponent just made them a reciprocal. Here are two for you to try on your own. So press pause, try these questions, then press play to check your work. For the first, finding the first term would be 4 times 1 minus 3, which is 4 minus 3, or 1. A sub 2 would be 4 times 2 minus 3, which is 8 minus 3, or 5. A sub 3 is 4 times 3, which is 12, minus 3, which is 9. And then a sub 4 is 4 times 4, or 16 minus 3, which is 13. And again, that pattern would continue. For the other, a sub 1 would be negative 1 to the first, and then 1 squared, which gives me negative 1 times 1, which is negative 1. A sub 2 is negative 1 squared times 2 squared. So negative 1 squared gives me a positive 1. 2 squared is 4. A sub 3 is negative 1 to the third, 3 squared. So negative 1 to the third, because it's odd, would again be negative 1 times 9, which is negative 9. And then a sub 4 is negative 1 to the fourth, which again would make that positive, and 4 squared, so it's 1 times 16, which is 16. This is what's known as an alternating sequence because the sign is alternating, negative, positive, negative, positive.